That'd be great. Anyway, nice to meet you all, and welcome to this H-line meeting, the H-line meeting. We're a bit short on the ground today. I'm guessing that's because quite a few people are probably on holiday, given that we're start of July. But thank you guys for making the effort to come and join us. And got Andrew here from the UK and Ted from the States, as well as myself from Staffordshire here in the UK. So, in terms of an agenda for tonight, I know that Andrew's got something that to present for us. I have myself a little something I put together on trying to reduce noise in H-line systems with the help of that wonderful presentation writing software called Chat GTP, which you can use for almost anything. So I thought it might be quite interesting to just present like 8 slides, perhaps just show that, and then ask you both what your thoughts are on what Chat GTP suggests. I just use it as a little bit of a talking point. So when it gets to my turn, I'll perhaps present that. And I don't know, Ted, if there's anything in particular that you would be keen to talk about as well. But just have a little thought.
I'm just keen with opinions. No, nothing special.
Nothing special. Okay. Anyway, would you like to kick off for us, Andrew?
Okay. Try and do this. If I hit share. Okay, so I'm going to talk about what we're doing at Norwich Astronomical Society with regards to hydrogen line astronomy, but our quest is to actually detect pulsars, and so it's a long quest, but we're working towards that. So I have to say, hopefully I'm among friends, and so I'm coming out, I hate Linux. Unfortunately, it's a bug you have to bear. I can't say I'm too enamored by Windows either, but I prefer to work with Windows rather than Linux. But there we are. So if we go into the history, way back in 1986, there were huge plans for radio astronomy at NAS. There was even talk about NAS being one of the control centers for AMSAT back in the days. And they did have 2 10-foot solid dishes that were installed in A-frames in 1996-97, but they were scrapped around 2000. They did have also a dipole radio Jove antenna, which was installed around 2002, and that was again scrapped in roughly 2010. So there have been efforts to do radio astronomy in the past, but they've never lasted or come to any fruition. So it was back in 2019 that 4 of us decided let's reintroduce radio astronomy, and our idea was let's build a 4-meter dish at the far end of sight, and that's where our journey began. So we started. We got this geodesic design from this Japanese fellow, Yoshiko Takayasuke, and we started working on building a dish and preparing a mount for it. And the Mark I version of the dish, you see there on the ground, which was fine until we went to pick it up, and then it just folded up like an umbrella because the framework material was too weak. Although we took the geodesic design from the online design feeds, and we just multiplied the size by 4 to get up to a 4-meter dish. We didn't take into account the effect of the strength of the materials that were involved. So the Mark I dish didn't get any really further than that, although we did put up the mounting post and the cabling to the control center. So then we went on to the Mark II version of the dish, and this one had a bit more structure in it, and it actually worked. We were able to get it up onto the SPID rotator on the mount, and we actually put the feed horn on it, and we actually started to try and collect some data on it. And we spent probably a couple of years trying to collect data from it, but failing miserably, and doing all sorts of things trying to understand why. But then we had a big storm come through, and with this design we had mounted the feed horn onto the dish itself. And because the feed horn is mounted about 1.4 meters away from the dish, the wind loading on it actually distorted the dish. So then we went on to a Mark III version. And with the Mark III version, we included even more frames inside it to increase the strength of the things. And we learnt from our mistakes. So this time we mounted the feed horn on the main axis. So it's not on the dish itself, it just goes through the dish. So it's a much stronger system. And that's the system that we have available and working at the moment. So it's a 4-meter home-built dish with a Pictor type feed horn design and a monopole inside it. And then again, we went through various changes. We did try to put coax from the dish to the control shed, which is about 30 meters away, but we found we lost so much data over the coax that we actually now have the detector mounted on the feed horn, and then at the back of the dish we've got the computer, which the detector is then coupled to by a USB cable, and then it's an Ethernet cable from there to the control shed. And we've got this whole thing set up so I can remote into it from home and control it from home. So that's quite convenient. And because it's on a SPID rotator, you can move the dish around and do lots of things with it. But typically at the moment, we're just using it in a drift scan mode, just trying to optimize the signal to noise that we can get out of the system. In terms of software, we use the GNU radio, so that's from the West Virginia University Radio Astronomy Laboratory. Their tools, which are obviously based on Linux. Also tried out SDR Angel. SDR Angel you can run on Windows or Linux. We tend to run it on Linux. The way I've got these set up, I've got microcomputers, but I've put an extra hard disk in the microcomputer that has Linux on it with the tools. And so you either use the default hard disk in the microcomputer, which is Windows, or you switch it and use the alternate one, which is then Ubuntu. And for processing software, I've self-written code using Visual Studio on C#. There are lots of problems. We tend to find that we have a 1420 megahertz peak. That's not the center. As you can see in the scans, the center I think was 1422, or it's either 1421 or 1422 in most of the plots. But we have this huge peak at 1420. We also have sometimes a peak at 1420.8. And then we also have noise. But all of these can be processed out, so they can be eliminated. So in the top plot, you see the 1420 signal, and in the bottom plot, you can see that I've eliminated that by just finding that peak and setting it all to an average of the noise level. So you can process out most things. And this is the dish results. So on the bottom, you've got the contour plot of the signals over time. To the left-hand side, you've got the frequency plot. To the right-hand side, you've got the velocity plot. And then you've got a radar-type scan in the middle, giving you an indication of roughly where the dish was pointing at the time that the signals were acquired. And you can see that as you move through it, you get a whole load of signals appearing and then disappearing at different velocities and frequencies. So this is a typical plot of what you can get with the 4-meter dish. using GNU radio. So I'll let it run.
And what is the receiver itself?
So the receiver is typically AirSpy, so it's either an AirSpy Mini or AirSpy R2. Either using the West Virginia University double amplifier filter amplifier system, or using Newelec H-Line and broadband amplifier.
It's quite a nice plot that you're showing on the screen there. Which software is that that's showing that? Sorry, the plot on the screen. What software has produced that?
So that's my own software.
Oh, right.
So it's Visual Studio using C#.
Okay.
And likewise, this one is the SDR Angel results. Slightly different plot, but again showing a drift scan using SDR Angel. And here I've got a plot of the intensity of the hydrogen line across the Milky Way, and the yellow dot shows roughly where the antenna was at the given time that the signals were acquired. So slightly different way of looking at it.
Ted, is that something that you've used, SDR Angel, at all? Not something that I've used.
I know about it. I think I may have run it, but I have not explored it. It looked like an opportunity. I may have thought about stealing code from it. I don't know. I keep trying to support new hardware receivers.
Yeah, I find SDR Angel a bit more flaky than GNU Radio because you have the basic program and then you load in different apps, and there's about 4 or 5 different apps you have to put on and tie together to get the radio astronomy to work, and it's prone to crashing. And the problem with the SDR Angel is that it saves the data to essentially an Excel file or a CSV file, but it only writes that when you stop running it. So it doesn't constantly write the data to disk. So if it crashes, you lose all your data. So I think that's probably enough running through there. I'll just move on now.
Mm-hmm.
Trying to understand the bottom graph.
Bottom graph there. That's intensity versus plot number. So it's looking at the
all right. So that's sample
frequencies.
Number going to the right.
Yeah,
Good.
and then you're looking at different frequencies and looking at the intensity of those frequencies across the plot.
I see. Okay. Yeah, and we can see they change differently. Sure. Okay.
Yeah, for different frequencies, different signals are coming in and out. So that's why you see the differences there. Yeah.
I like your bottom right image, but I think it implies that you're always in the galactic plane.
Oh,
I'm
yeah.
not sure that's true.
No. And you know, it's probably well out of date because we'll have moved. Okay, so we also have feed horns, and so these are the typical feed horns that we have. The galvanized steel, because that bends much more easy than aluminium does, and so they're just feed horns. I've got a mini one of these that I use for demonstration purposes, but on the right you can see 2 feed horns being used for interferometry. There's one close to us, and then there's one right further away as well, and the computer's in the grey box in the middle, if you can see that. But these are the same sort of receiver systems that are on the dish. I move amplifiers and detectors around, but this is looking at interferometry. And with interferometry, you've got 2 signals coming in, 2 different detectors, and because of the way that the waves come in, depending on the angle of the object you're looking at in the sky, the phase of the signals reaching the 2 detectors will differ. And so if it's directly overhead, the phase angle will be 0, and when you do the sum, you'd get the sum of the 2, and if the phase angle was 45 degrees, they'd be completely out of phase, and when you sum them together, you get nothing at all. And so we've done some interferometry work as well, but with interferometry, we've just been looking at the sun. And so again, this is using GNU radio and looking at what the effect is as you move the dishes further and further apart, from 2.5 meters apart to 20 meters apart. And what you can see is that the frequency of the signals increases as you move the dishes further apart. So the resolution gets better as you move the dishes further apart. But that's adding interferometry results. You can see there. You can also do interferometry by using multiply, and these are the results you get with multiplication. So you get larger signals, but the phase is slightly distorted by the way that the multiplication goes. So, but we can do interferometry. Again, I would like to be able to try and do interferometry on something else other than just the sun. But at the time I was doing this, the only dual detector that I could get hold of was the SDR Play Duo. And if you use that in a dual mode, you only have a 2.5 megahertz bandwidth. So I was looking to try and see if I could find ways of doing this with a larger bandwidth. Actually, I've managed to purchase a blade, Nuant blade detector, and so hopefully I can go back to this at some point and try and get better results and try and do interferometry off the reflection off the moon or something like that. But this was an experiment a while ago. And so that's it.
Oh, it's
RSP Duo. That's it.
Yeah. We've just had it. Just Adrian's just joined us, so.
Can you hear me now?
Yeah, absolutely. Brilliant.
Fantastic. So sorry. Microsoft and my ancient laptop just didn't seem to want to work with the microphone, so I just tried rebooting, and I apologize for just dropping out like that, but I guess rebooting did the trick. So sorry.
Don't worry. It's nice to see you back. And unfortunately, you've just missed Andrew's presentation. Have you got
I know. I would have loved. Maybe I'll just catch it on if you have a replay. I apologize again. I would have. As you can see, I have one of those SDR Play Duos. I was planning on utilizing it also for application using. Well, it's backwards. Using 2 antennas and then receiving simultaneously with 2. And I just caught the very last part there where you address that one problem where you only have the 2 megahertz bandwidth, and so I'm not sure how that affected your observations, but I figure for hydrogen line that might not be a big problem. But sorry I missed your application there. I apologize.
I mean, as far as I'm aware, if you can increase the bandwidth, then you get better signal to noise.
So out of interest, Andrew. So if you so let me forgive me for asking basic questions. So for interferometry, you're using the duo, and I assume one of the horns goes into one uh, entry on the duo, the other one goes into the other entry on the duo, and then what GNU radio just takes both signals and plots them together, does it? What happens?
Yeah, so GNU radio then takes the two independent channels in, does some processing on it, and so some basic filtering FFT, and then you add them or multiply them and spit out the results.
And that's within the GNU radio software options itself to add or multiply.
I got that from the West Virginia University, so the WVU or UV rail. If you get their code off of GitHub, it comes with the interferometry options in there.
And that's the GNU radio that you're talking about, is it?
Well, GNU radio is the base, and then you add the radio astronomy features to the GNU radio.
Yeah, have to forgive
So
me.
they're
I've never used it, so I'm just interested. Yeah.
Yeah.
Okay.
Andrew, that was exciting. All this fun hardware you have there. I'm impressed with the interferometry too. I'd like to explore that. So thanks for the clues. It's neat to see all this stuff in action.
Yeah.
Oh, that's fantastic. That's fantastic. Thank you.
So are you planning on utilizing two independent receivers? Because I guess the advantage of the Duo is that the two receivers are synchronized. They're using the same clock, and so they're in phase. So for interferometry, I guess that's the requirement.
Yeah, I've purchased a blade, Nuant blade, which obviously has broader bandwidth, but I've been having problems with that using it on the dish. I'm just not getting signals out of it, so I'm not sure why. So I've been playing around different receiver chains, different amplifier chains, just trying to figure out what's going on. But at the moment, I've put the blade aside and I'm back on AirSpy on the dish.
Well, there is an option. The Duo does have a clock input, so that if you had a second SDR play, you could use those in the single mode with the combined clock, and then have the full bandwidth.
Mm-hmm.
So that might be an option. I mean, they're close to $300 or so, but that might be an option. And since you obviously are getting maybe one to sort of work, the second one shouldn't be a problem. But that might be an option. You just have to utilize I guess an external clock to synchronize both.
Yeah.
That might be an option. I don't know. I think I'm not sure. I'm not familiar with the blade, so I can't say anything about that.
I mean, I did try and look for the Lime SDR, but that's no longer available.
I think it was about £600 or £700 as well, wasn't it? I think.
Well, the blade was, that sort of order.
Well, thank you very much for that. Adrian, do you fancy telling us about anything at all?
Oh gosh, well you saw my Duo there. I'm still working on a system and trying to build up. I'm having some housework done, and it's just kind of a nightmare around here with people utilizing the areas around the house and space and stuff. But what I'm trying to do is the plan is to utilize the Duo, and then on the antenna that I'm trying to design, it's just basically the same design, similar to what you're using, Andrew. But what I'm trying to do is I'm trying to do kind of like what the Green Bank telescope does, and that's have the dual polarizations. So on the antenna, utilizing the two probes, the two linear probes, orthogonally at 90-degree angles, to be able to obtain those two sort of polarizations, and then using the duo to essentially do a 2-for-1. So you basically then doing the reception with the two polarizations, so that then you can then average them together and perhaps get a little bit better signal to noise ratio. And then I'm still debating whether to convert an old satellite dish that I have mounted on a pole, which is the easiest one, and then the second one is to try to assemble kind of a similar thing that you kind of got me started on, the solar cooker dish, which I've purchased one of those, but it's still boxed. I haven't had the opportunity to even get that put together, and then so debating whether to start out with that, which would be a little bit easier on the ground, because the elevation would be easier to adjust, and then the dish that I have has no easily adjustable elevation. It can do azimuth. I have has a motor control, so we can do what they used to call horizon to horizon scanning, but this would be, of course, only at the one Clark built elevation where the geostationary satellites are pretty much that's what the intended application for that. But so it would have to be climbing up on the pole and unbolting bolts and then adjusting the elevation for it to do the different scans for the galactic hydrogen. But anyway, that's kind of the idea that I'm working on. And of course, with the system, the solar cooker, then trying to devise a base for it, as you've done. I guess you just were able to assemble some lumber to provide kind of a stationary base for it. So I'd have to contrive something along those lines. I was contemplating if maybe just some large diameter PVC tubing could be somehow manufactured to do that, and then able to use some kind of an elevation system to more easily adjust the angle on that. But right now, my main goal is just to try to start working on the actual dipole antenna system, and at least get that set up. And I do have a nano VNA, which obviously is indispensable to trying to tune it up for 1420, and trying to adjust it for that. So got the bits and pieces here coming along. It's just the effort of trying to get everything assembled to get that rolling on the ball. But I had a question for you, which that's such a wonderful page that you set up for your muon detector that you were presented yesterday at the RTOP meeting. And but I was curious. I was looking at one of your plots, that very first plot that shows up on the page, and I swear that I would almost see, and I think I looked at your timing on that, your time course, and it almost looks like about every 6 hours or so you get kind of like a little peak of the muon count. Am I imagining that, or is that real?
I'll just check with Ted and Andrew. Do you object if I show that page for a second? I know we are a H-Line group meeting, but is that going to be?
Oh gosh, it's just astronomy,
That's fine. While you're getting that ready, I will ask. I'm interested in your dual antenna, because we've tried playing around with that. Actually, on our dish, I've got two monopoles at 90 degrees apart.
Oh, wonderful.
And we've been trying to do coincident interferometry on it to improve signal to noise, but had no real success. So at the moment, I've got it running where I've got the two going into a T-piece, feeding into the amplifiers, and just using both of them as detectors to try and help improve signal to noise. But I'd be interested if you get some success.
Well, I wasn't intending on combining them. So you're just basically using a combiner, like a dual.
Yeah, I've tried independent, trying to go through independent amplifiers, and treating them like interferometry, but I haven't really improved signal to noise.
Oh.
You multiply the noise the same way you do the signal.
Well, true. Although it might, I mean, the noise is random, so I don't think polarity would. And of course, a hydrogen line doesn't really have much of a polarity to it.
No.
So if you're doing hydrogen, that's not going to be any advantage. But I was just thinking that independently, the noise might be somewhat random, but the signal would be perhaps, since there's no polarity to it, the signal would be a more uniform signal. And so subtracting the noise from that, you would think maybe would give you, since the noise is random, that the difference would give you a slightly better signal to noise ratio. But that's just my theoretical thinking on it. But I have no practical data to prove that, since I haven't constructed it yet. So, but that was just kind of my idea, since I did have the duo as you saw there, and I thought, well, gosh, if I can go each into the independent receiver, and so you're doing two observations for the price of one, that signal theoretically should give you some advantage. It might not be 2x, but maybe some function, some square root function or something that should provide a little bit better signal.
That was our thinking, but as I say, I haven't been able to prove it yet.
Not in practice. Well, as most things in life, you have to. The theory doesn't necessarily always apply to the reality. So that, well, that's interesting that you've tried that. So you have a similar antenna with the two probes that.
So I've got a Pictor type antenna on the dish. So the tube in the center with an extra horn around the outside, like the Pictor design, and so it's based on that.
Okay.
And that's tuned with the nano VNA.
I see. Well, that was one of my concerns, is that there would be an interaction between the two dipoles, so that as you're tuning one, when you combine them together, then there might be some interaction that might detune the system. So that was kind of one of my concerns, and I couldn't think of how unless you had a second VNA where you could simultaneously do the scan on both at the same time, and see if now with both of them interacting would change the tuning. But that was what I was thinking would be maybe a caveat for the signal being any advantage. So I'm not sure if that's the case, but that's the one thing that I had thought of. But I can't. Again, I don't think what I would like to do is combine them both. And since I'm not really interested in interferometry, I was just trying to boost the SNR, and so going independently, each one into the receiver. But you said you've tried that and also haven't seen any advantage. Which and what size dish are you utilizing?
4 meters.
Oh my gosh! Wow. Okay. Well, the best I can do is like a 2.4, and that's the thing that I have on my pole in the backyard, and so that was the one that I was thinking of maybe modifying for H work.
I encourage you to still go ahead, and then if you get some success, let us know what you did.
Well, absolutely, yeah. Again, this is just theoretical at this point.
Yeah.
But, wow, that's interesting that you had tried it and didn't see any results. I would have thought it would have been at least some noticeable improvement. But because the other thing I had thought of is just doing foregoing linear polarization and then just doing like a helical feed, and then just doing a single helical feed, and then just going with that. But again, it wouldn't be of any advantage. I don't think you're gaining or losing any signal because of the non-polarization of the. Another thing that I would have loved to do, I don't know if I have the aperture to do that, is to do some macer work. And I've used the GBT, the Green Bank 20 meter, to do some macer views of the Orion Nebula at 1665 megahertz. And that works really well with the GBT at 20 meters. And so that's kind of the things I would have liked to proceed on after maybe getting some my feet wet with the hydrogen. And so that's and then with macers, of course, they do have polarization.
Yeah.
So that's why I was thinking of maybe going with the.
Well, it's just worth saying that Eduard Moy, Sarah, he looks at masers with a 1 meter dish.
I thought he had like a 3 meter. I thought he's using a 3 meter.
No, 1 meter.
Oh, he has a smaller.
Yeah.
He has a smaller dish that he uses. Oh, okay. Well, then the 2.4 should definitely maybe requiring a little bit more integration. But yeah, well, that's encouraging. That's encouraging. That's kind of one of the things I'd kind of like to get into. I would only hope for pulsars, but I know that's just
well, the smallest size that I know is being done on SARA, unless Ted knows anything different, is 3 meters. Do you know anything different, Ted?
That may be true. I tried with our 15 foot, so what would that would be 5 meters, and we just have too much noise at the 1420 frequency, or my feed above my ear on that red stick just is insensitive. So my next attempt was going to change that to a Cantenna for a feed and try again, or try another frequency like 400 megahertz, where apparently at least the big pulsar that everyone starts on, what's it called, plus 59 or something, and is louder at that 400 megahertz. Yeah. So that was something I was going to try. Yeah. I have a list as well.
Yeah, I know Edward does it at 1 meter because I spent a couple of sessions with him, and it's one of my projects I intend to do, and I got the kit. I just need to find some time to put it together now, because he actually does things surprisingly cheaply. The Mazar thing, you need to get the right LNB. And they can be a bit difficult to pick up. But I was lucky and one was being sold on the eBay.com American website at the time, so I picked that up.
And that's just because it's such a higher frequency, you're saying?
Yeah, but it's one particular one. I think it's meant to be 20 gigahertz, but you can tune it up. So he's discovered up to 22 gigahertz, which is one you need for hydroxyl masers.
So you're talking about water masers up at 22 gigahertz.
Yeah, well, I think it's hydroxyl masers. I'm not sure. They're the same thing as water masers. I'm not sure.
No, they're different. Yeah, the OH masers are the ones that are around just above the hydrogen line, and 1420 for hydrogen.
Oh, are they? Okay, well,
like
I'm mixing it up
1665. Yeah, and actually, there's a second one also, which is also quite doable, and I think Edward has done that, and is it Sergey, the other person that does the macers work, and that's the methanol macers, which are at I believe they're at 6.6 gigahertz.
All right.
So
it's the 22 gigahertz I'm talking about, whichever one that one is.
Those are the water macers. Yeah, that's H2O, not OH.
Yeah, so forgive me. Yeah, you're absolutely right. I just looked it up. 22.23508 gigahertz water masers.
Yeah, right. There's a because the LNA that he uses is quite trendy. I forget the trade name for it. There's one that's slightly cheaper that out here in the U.S. things are a little bit harder to get from China now, but from Alibaba, there's a company that has a 22 gigahertz Ka band, is what they call the Ka band for satellites, LNB, and there's no advantage to it except that it's a little bit cheaper than the one that Edward uses, which is I don't know if he uses Norsat. It might be Norsat. It's the brand of the LNA that, but they're both what they call DROs, which are these dielectric resonant pucks, which are not very stable oscillators. They tend to drift significantly, unlike the so-called phase lock loop or PLL local oscillator LNBs. And I believe Norsat does have a PLL one, but that's like just the price range on that is way up there. And so I think they've gone to the measures of having a reference signal. They use one of these GPS controlled oscillators at a harmonic. I think it's a Leo Bodnar one out of actually UK there that sells those. And so using a harmonic for that is a very weak signal just adjacent to that, so they can use that as the reference frequency standard, and then they can compensate for the drift out of those DRO units. But 22 gigahertz is that's challenging, and the feed for that is just something that you'd have to probably the dimensions and accuracy for that would not be something that would be easy to construct unless you have a full-blown machine shop for metal work and lathes and so forth. The feed for 22 gigahertz would be something that would have to be purchased. But it's just like we had that discussion before about the carbon monoxide reception up at 116 gigahertz or something, which is, as far as I can tell, it's just unobtainium for him. I mean, that would be, and now if you did have the equipment for that, you probably could be able to pick it up, because they're not point sources that carbon monoxide is distributed throughout hydrogen clouds also, and so you would not have to necessarily have a pinpoint large aperture, kind of like what Edward was doing with what he presented yesterday on the radio recombination line work. Where he was able to just get the sensitivity just because the emission there from Cygnus is such a wide area that his dish could utilize the full signal. And so I read the papers on carbon monoxide, and they were using a fairly small dish. The challenge there is just the frequency, like 116 gigahertz or something. That's just wow. I'm fascinated by microwaves. I have license, and I've done some work at 10 gigahertz, doing some communications at 10 gigahertz, and that's kind of a challenge in itself. But 100 some odd gigahertz is just beyond belief. But
well, I know that I mean, the way that Edward does it in terms of the water masers. So you get the LMB, the one that you're mentioning there. So they're around about the sort of $200 mark if you can find them. As far as a feed is concerned, he just uses a piece of copper plate which has been cut with snips and bent around. That seems to work. Then he has a 1 meter dish. It does need some integration time, so he puts it on a HEQ5 Skywatcher HEQ5 Pro mount. I mean, the LMB actually converts the signal down to something much lower, so you don't need to worry too much about trying to have coax that will take 22 gigahertz down to your SDR.
The standard SDR would the intermediate frequency is not a problem. That's just a standard SDR, but it's just the LMB that's the requirement there.
Yeah. But it's the important bit about this particular one. Did you say it was Norsat? Did you say?
I believe it's Norsat that has it. Yeah, And they do have that other higher end model. If you've got the bucks,
yeah,
you can get
but
the PLL, which is really the one that you would want to use. But
yeah, but
you can work around it, as I said.
well, the point about this one is he's discovered if you take the top off, there's a little screw in it, and you can turn the screw and tune it up by 2 gigahertz. You can get up to
Yeah,
the 22, even though it's
right.
not technically designed for that frequency.
Yeah, they're
Anyway,
at those frequencies. Those things are wide bandwidth enough so that tuning it up a little bit is not gonna make a big difference.
yeah.
Yeah, it's just the stability. It's just the stability of the local oscillator that's just going to give you a lot more frequency drift uh, with the that system. Which for satellite work it doesn't matter because those signals are so they're 6 megahertz or 15 or something, so you don't need narrowband work. But for masers, they're also fairly, it's a narrowband signal, so it's a lot narrower than the TV signal. So that it makes it a little more of a problem because it's going to drift. But if you have enough bandwidth and a reference frequency standard that you can use, then you can compensate for it. But it would be just nicer to have a much stable local oscillator. You can always modify one if you've got the technical expertise. You just pull out that ceramic chip and modify the circuitry where you're feeding in an external local oscillator signal. You can derive the multiplier chain and so forth to get it's 22 gigahertz, so you probably need something around 21 or something to bring that intermediate frequency down to around 1,000 megahertz, around 1 gigahertz in the range of the SDR. And so, you need a stable local oscillator signal that you could then inject back into the LNB and just do away with the DRO. And that's an option that I've thought of. But still, working at those frequencies is pretty. In my experience, even with 10 gigahertz is kind of finicky to try to get things to match up in frequency, and then to tune it, you would need something, a system analyzer, kind of like a VNA, but it goes all the way up there to 22 gigahertz in order to be able to do the tuning, and that does not come cheap. If you get an old unit or something, a used Hewlett Packard or something unit here in San Diego, there's what they call the San Diego microwave group, and the guy that more or less heads it used to work for the big phone company Qualcomm, and when they got rid of a lot of their analog equipment, a lot of those test equipment that for all these high frequencies, they just kind of passed on to him. He just took it off their hands rather than having them just put it on the trash bin. So he has a whole garage full of this test equipment that he lets people utilize that join up in the amateur microwave group. They're mostly interested in ham radio, not radio astronomy or anything. So that would be a possibility, to be able to utilize some of that loaned equipment. But getting up to those frequencies is just kind of a real challenge. Even the 6 gigahertz, the methanol masers, which I think Edward also does, the 6.6. That's more doable, and I've actually purchased a partial receiver for that. It's kind of the front end. It doesn't have a local oscillator, so it's not like a full LNB. So you still have to provide a local oscillator for that to derive your intermediate frequency that would then go into the SDR for reception. But that's doable, and that's something I'd like to try at some point. But the methanol masers, and they're fairly strong signals, so it's not undoable. But
Okay.
Wow. Well. So
Okay,
unfortunately, I don't have no data yet. Just theory and trying to get things assembled here.
Wow.
But I'm really fascinated about your dashboard there for the meal
Oh, of course.
detectors.
Oh, yeah.
That's
Forgot about that. I'll just briefly show that.
sure. That's really neat. I really like that dashboard. It's really nice.
So here it is. I mean, this shows the last couple of days. That the blip in the middle there is because I restarted it, and when it restarts, the two muon detectors default back to master master, which means you don't get the master slave coincidence configuration, and suddenly you get larger numbers coming through until I remember to reset it. But if I take it back the last maybe the last 7 days, that should. Oh, there you are. So you can see that the average number of muons is 0.17 counts per second. But I can see what you mean now on that signal.
Those little peaks. There's almost like a repeating set of those little peaks. I don't know. I kind of was trying to squint at your timeline, and it looked like about every 6 hours or so. And that does not match with the Earth's rotation or anything. I'm going like, wow, what is that periodicity? It just seemed like really interesting. It just caught my eye. I don't know. Maybe I'm imagining it.
Well,
seeing things.
If we ignore these smaller ones, we seem to have one here.
Yeah.
That's, I don't know, around about 10 o'clock at night, and one that's sort of like I don't know, about 6 o'clock in the morning, and then or maybe 8 o'clock and 6 o'clock, and then another one. That's about 4 o'clock, and that one's about. It looks like about 10 o'clock again, and then about 4 a.m. and then so maybe 10 a.m. I don't know.
That's neat. That really is neat. I'm just curious what could cause that.
I don't know, but the next one down is showing binning every 5 minutes, and when you do that, it seems to have lost that regular bumpiness.
Yeah.
It's still there. It's a bit suppressed.
You can sort of see it on the baseline there. You see the little kind of wiggles that kind of seem to correlate. But I mean, I'm just baffled. It shouldn't be there. you shouldn't get that periodicity with muons, because the cosmic rays are fairly, unless you have some untoward event in the nearby sort of galaxy that spews out a huge number of cosmic rays or something, and but that kind of periodicity just kind of baffles me. It couldn't be solar, because solar cosmic rays or protons, whatever, they don't usually have the energy required for the interaction to generate the intermediate part, these pions. I think we've talked about that in the past, that then decay into the muons, and you need significantly higher average MeV energy to kick the pions out of atmospheric gases when cosmic rays interact with them. So it should be sort of a fairly semi-constant sort of rate. The only variation that I have read about is like with the solar cycle, the 12-year solar cycle, because then the magnetic field of the sun is altered every the 12 years when you go through the pole reversals in the sun, and you get sort of a variation of the the heliosphere, the magnetic influence of the sun into the nearby interstellar space. And I forget during what period you do get slightly more leakage of cosmic rays that get through the Earth's the solar magnetic field, impacting the Earth. So you do see some kind of supposedly kind of around the 12-year variability in terms of these cosmic ray events that would then presume would generate the flux of muons to alter here on Earth somewhat. But that kind of short-term periodicity just baffles me. What could be causing that? Anyway, just thought I saw that.
If you looked at the red plot, which is biased because there's a very large peak, but if you expanded that, the periodicity is in there as well.
Still there, yeah, to some degree, yeah.
I can see tiny little things coming up here. Yeah.
Yeah.
These, as you say, that large plot is a real nuisance. I'm going to have to restart it. That was my son playing around with the computer. He'd set it up with so I had some sort of desktop access remotely for Ubuntu, but it wasn't quite exactly the same as the one on the computer, so he wasn't happy with that. And in doing so, the whole thing got restarted and it mucked up the data. I was saying to him, I'm very happy with it the way it is. No, that's not good enough. But there we are. He goes back to university tomorrow, so I can get some peace.
So you have the way that system works is now are you using this new muon detector that the BAA or group has put together that has the two detectors built in, or is still using kind of the independent detectors that have to be adjacent to each other in order to get the coincidence counting?
Wait a minute. I will answer that question in a second.
Oh, okay, no problem.
I'm sending myself a picture. Picture speaks 1,000 words, as they say. It's easier than trying to explain. Well, I can explain it with a picture, which makes it easier. Have I got it? Come up here. Come on. So many windows open on this, it's ridiculous. Ah. Sorry to keep you waiting. Just taken it next door to me, so I've got the new Pico muon detector there, and on the left are the two old Cosmic Watch detectors. So the Pico muon detector has its own very good software, which I can show. So I didn't need a new dashboard for that. Oh, look at that. Oh, hang on. So there we are. So that's the last 24 hours of the Pico muon detector coming through, and then variation graph compared to Uluru in Finland, and the last week, and the last month. You can see where it got turned off at one point. So that's the Pico muon detector, but the Grafana dashboard is the one that's picking up those older muon detectors, which you can see there are on the left hand side with the 5-volt 1 amp thing stuck on the side of it. I tend to do this. I write instructions over everything so that if it needs restarting, I don't have to sit down and try and think it out. You see some of these mini PCs on the left, they're saturated with bits of paper stuck all over them. What to do?
Those systems, they only give you a count. They don't give you a detection intensity, do they?
So if you look at on here, I mean, when you say intensity,
well, my original thinking is in terms of the muon energy.
Yeah.
And so a more energetic muon might perhaps give you because the system works on a kind of a flash, right? The fluorescent material on impact by muon gives a flash of light.
Yes.
So that flash of light should be sort of proportional to the energy of the muon. In other words, as the muon collides with some of those fluorescent molecules, the more energy it has, maybe the more molecules it interacts with, and you get a brighter flash. Is what I meant by intensity.
Yeah,
and
the Cosmic Watch does give you bins of intensity.
It does. Okay.
I mean, the first thing to say is that you're picking up the muons at sea level, but of course they reflect the protons coming in at the top of the atmosphere 20 kilometers above our head. So to a great extent it's not directional. I mean, you can debate that to some extent if you've got things pointed in different directions, but the official Cosmic Watch muon stance is it's not directional. I know because I asked them. Then obviously the whole issue of time dilation. Just a few alternatives. So that's a picture of the construction. So within the device, you've got the scintillator, which is 5 by 5 centimeters and 1 centimeter thick, covered in the super scientific black insulating tape and kitchen foil, with a tiny spot left open for the SIPM, which is the detector, wherever you decide to stick that. So it's a 5 by 5 centimeter. So in reality, the detection of this is this 5 by 5 centimeter block. So when you put them in coincidence mode, which is effectively one on top of each other as shown here, but the rest of the box doesn't matter. The question is, where are the two plastic scintillators in respect of each other? And if you look at the size of these boxes here, in practical terms, if they're put normally on top of each other, I think that equates to about 2 centimeters between them. You could slightly reduce that distance by turning one of the detectors upside down, the one on the top, because as you can see, the plastic scintillator is towards the top of the detector. So if you put the second one upside down on top of it, they're closer together, which will give you a slightly better coverage of the sky, gives you a slightly better angle, because the angle they subtend. Can you see my cursor?
Oh yes, absolutely.
Yeah. So the angle of sky you pick up, I believe, equates to sort of there up to there, and there up to there. So the closer they are, the bigger the angle of sky you will cover. The further away from each other, the less sky you will cover with the detectors. And it works that any count that occurs in the bottom detector within 3 milliseconds of the one at the top detector is counted as a coincident event. And the assumption is that's the same particle going through the top one and hitting the bottom one. They are sensitive to alpha particles and beta particles as well. And I think they're also might be sensitive to gamma rays, I'm not sure. But certainly, they're certainly sensitive to alpha and beta. Sorry?
I don't know if gamma rays would do it, but definitely alpha and beta.
Yeah,
definitely any particle.
Yeah, because the reason I say that is I know that here, this is my presentation I put together using their graphics. So this is meant to be a little bit of uranium-containing rock, which they've stuck on top of the device, and you can see how it picks up that signal and drops off the further away you go. Or using my particular radioactive test rig. Here we are. That's my radioactive test rig, the banana. And you can vary the number of bananas, obviously, and then you can test the bananas to make sure they're real bananas afterwards. All sorts of good scientific principles. But
yeah, that's the potassium. I think it's 45, the isotope that decays and gives you the particles. Yeah,
that's right. You can factor even go around different supermarkets and buy bananas from different people and check who's got the most radioactive bananas if you want to. All sorts of serious, exciting experimental projects you can do with this.
Oh boy, that would be curious. I would suspect it's probably fairly equal, not too different. But yeah. So
that's the basic design principle.
If you happen to have a very old luminescent clock or watch that had the radium painted hands, that also makes a very excellent source with radium. You can find some of these old clocks that had the fluorescent hands that utilize that radioactive radium with a fluorescent with a fluor. So essentially, the fluorescence then would be visible at night to tell the time. and those make excellent radiation sources also for, yeah. Um, yeah, so the idea, of course, is that an alpha particle or a beta particle would only penetrate enough to give signal on one, and would not go all the way through and interact with the second detector.
Well, it'll be coming in different directions, so it's not very likely to be going from the top down. I think that's the idea, because you have a reasonably high rate of this.
You're also generating beta rays and electrons, high energy electrons, and alpha particles surrounding you, materials, concrete that has radiation on it, and so forth. So all those would be local interactions that would give you indications on one of the detectors, but it would not give you the coincidence. You wouldn't have the energy to essentially penetrate through to the second detector and give you the coincidence signal. So only the mesons have that kind of higher energy, because they're more direct particles generated from the cosmic ray impact. But I mean, there's radioisotopes all around. I mean, you're radioactive with carbon-14, and that's a beta emitter, but that's a very weak beta emitter. So, you can put your hand over it and probably not detect it. Not your carbon-14
Anyway,
emission.
this is the radioactive source I've got hold of, which I use, which is one of these thorium-based gas battles. So you can still pick them up off eBay.
Oh, sure. Yeah, they don't make those anymore, so they don't like the thorium radioisotopes hanging around. Yeah, that's also a useful radioactive source. Anyway, I just thought I spotted that the other day. I was just kind of curious what could cause that. Are these things run off of like a regular house mains supply?
No, they're just through a USB cable off the computer.
Oh, the USB from the computer. Okay. I was just curious if maybe some kind of a voltage variation would maybe provide.
No, it's just powered through the USB cable. But it might be on the computer. I don't know. Anyway, okay. Ted, I was thinking. I mean, you showed us your picture of your folded taco at the beginning, taco dish, and then had the replacement. But that was before we started recording, and I don't know if Adrian saw it. I wonder if you could show us it again.
I'll push buttons here.
I forget. Were you here when that was shown, Adrian?
Not today. I think Ted might have provided that at some other point. I seem to recall this horribly mangled. Oh, what a beautiful dish.
So that's the before picture.
Oh, gorgeous.
That was grand.
Oh my goodness.
But things happened.
I don't. Oh,
It
God.
got folded in half.
Oh.
They said 70-mile-an-hour winds up there at one point, and the poor thing just had trouble.
Oh.
And so that is now in my backyard as parts. Maybe we can use it. But as of Saturday, I went up there and have a seed for a new antenna. And Andrew's right, it looks just like a twig coming off an old dead tree that was hit by lightning or something like that. And maybe it'll grow.
What was the size of the dish?
It was a 10-foot dish.
Oh gosh, yeah, wow, nice. And that's an active drive that was attached to.
Yeah, it had a spit drive underneath it, and run by MIT Haystack SRT program. It was an official one of those dishes. They had trouble eventually controlling the motors, I guess it was. And I came along 5 years after everyone had left and was able to finally figure it out. So that's where I started with radio astronomy, with my own private dish already built in cement. It was nice.
Yes, that's a shame. It's a horrible shame. Gosh.
Anyway, that's the funny story. That's all.
Yeah, I've got a challenge for you, Ted. You need to get yourself a soft mallet and bang that dish out until you tune it back to effectively pick up 1420 again.
Well, I kind of agree with you, and so yeah, I was going to study it and see what I could do. There's a ring left and things like that, and the feed looks pretty good. So okay, but that's how I got to going with the Ezra stuff by getting a signal out of that 10-foot dish, and now what do I do with it? So yeah.
Or wait for another 70-mile-an-hour wind and turn it into the wind.
Oh yeah, that's right. Turn it around. It's got motors, Dad. Come on.
Just like
The other
an
problem is
umbrella.
the poor thing wasn't tied down, and it rattled back and forth, and eventually broke a tooth in the gears. So I got to figure that part out.
Oh, that's.
And so now the dish behind me with the red stick is tied down to prevent it from big winds.
Hey, I've got an idea.
Lessons.
Why don't you attach it to a pole, right through the middle, and put it on the back of your car, and then drive down the highway at about sort of 70 or 80 miles an hour until it fills up and blows itself out.
I see. Yeah, that'll just undo it. Okay. Very good. I'll tell you all about that next week, or not. Yeah. maybe I won't be here next week. We'll see. Yeah.
I had sort of a similar situation, but not anywhere near to that extent. It just sort of distorted the dish a little bit, so it wasn't now a perfect parabola. But and I just sort of was able to kind of manhandle it back to where it's approximately now a parabola, although I'm sure the surface accuracy, and this is the 2.4 that I have on a pole in my backyard, and so that's kind of why I'm not really. If it were perfect, I mean, it was so tuned, it was so fantastic. I was able to pick up all these weak satellite signals and whatnot, but after that, it distorted the aiming somewhat, and just kind of manhandling it back to an approximate parabolic shape. Seemed to still work, but it definitely lost efficiency on a bad windstorm here in California. So yeah, I don't think it was a 70-mile-an-hour wind, but it might have been a 40 or 50 sufficient enough. And the thing is, my backyard looks upon a canyon, so these canyons here in Southern California, and so that acts kind of like a wind tunnel. So when the wind kicks up, it kind of funnels through that canyon, and then it climbs up the back of my property into the close to where I have the dish planted, close to the edge of the backyard. That goes into the drop off like 300 feet down to the canyon, and so it kind of incline effect of that wind gust coming up from the canyon is what caught it one time and just sort of warped it somewhat. Nowhere near to that. No, that puts tears in my eyes seeing that. Oh, what a shame. I can imagine what these people that have, my gosh, the people that have that, 10 meters and dishes. How do they manage to deal with inclement weather like that? It's just.
Okay. Have you got anything else about H-Line you'd like to speak to us about tonight, Ted?
Not me. I'm here listening, fascinated by all the goings on. It's great.
I've just asked ChatGTP how to fix your dish, so I'm sending you some instructions, care of ChatGTP.
Are they creative?
You know what? I've actually heard of people that manufacture their own dishes, and what they've done, and this is incredible. And it depends on what kind of tank you have. Is these large propane tanks? The ends of propane tanks have almost a perfect parabolic end. I mean, you've seen it, the cylindrical gas tanks. There's some people, especially in rural areas where they don't have gas service, and so they just have the the propane brought in and fill up their tank. And so some of these tanks that are fairly large diameter, and people have just made a mold out of the end of the dish to form like a fiberglass mesh over it, that they can just use that parabolic shape off the end of the tank, and then line the inside with a metallic mesh or something to generate the reflecting surface. And I've just read of people constructing fairly large dishes out of these ends of these tanks that they've used as the mold. Because I guess the hard thing is just being able to get that parabolic shape in order to be able to form that in one piece. I mean, if you do the construction where you do the single members, where you do the ribs, and you can cut the ribs and then fill in the gaps in between the ribs with mesh and so forth. But for a solid dish, it's very difficult to get that parabolic shape. So maybe if you go around the countryside there, Ted, and find somebody with a very large propane tank, and just take your dish and kind of spread it out with a mallet, and just kind of.
Oh, I see. Yeah, okay.
Form it around
I like
the.
that.
Yeah, forming it around the end of that propane tank, so you can restore that parabolic shape to it, and maybe that would work. Just a thought.
So you say the citizen probably shouldn't be at home when I'm there banging on his dish, huh?
They might not have
dome.
on the propane tank. You bang on it with a hammer, might not go over too well. They might get that 12 gauge out and kind of chase you away. Yeah.
I was more concerned about cutting off the end. Okay, you do it. You get a torch and start lighting up, cutting the end of the propane tank off. So yeah,
Well,
I like
you
the
don't.
method. What I'd like to do is then make a paper mache dish, right? Just keep wrapping stuff around it.
Well, you use fiberglass mesh and the epoxy, and then you just make the mold out of that. And then all you have to do is then just line the mold to the inside with a reflecting surface. So you don't.
Yeah, some
You have to cut.
silver paint or something. Yeah, that's it. Yeah.
Well, I don't. Well, the paint might not work, but you can certainly get some mesh and then just apply it to the inside of the mold. Anyway, just something I read somewhere and which fascinated me. I said, well, wow, people are so inventive. They figured out that the end caps of these big propane tanks have a parabolic shape. I guess it's because of the pressure. That's a good shape, I guess, to withstand the internal pressure of the. You don't want a flat sort of surface that doesn't have any structural integrity for the pressurized gas inside the tank, and so they round off those ends, and that rounding is a pretty good parabolic shape. Anyway,
I was just thinking if you could get a spark inside the propane tank, it would probably blow the end off for you, and then you could use that as your dish.
I mean, you can think of all kinds of crazy ideas. Again, I thought this was pretty wild in itself, but just a very sort of out of what anybody would come up with. But that's again, I read somewhere where somebody had done that or had constructed their dishes that way. So, but pretty innovative, I guess.
Okay, I've got 8 slides on trying to reduce noise in H-Line radio telescopes. So do people like me to show you those, or are we got to the stage where everyone's feeling a bit tired? I'd like to leave that for another day.
We're ready to hear what you got.
Well, I asked ChatGTP to give me some ideas, so this is what it came up with. I'll blame it, and so it's just something to give a bit of a talking point, really. So very briefly, so ChatGTP suggested you were looking at internal, external sources of interference, trying to reduce those or the effect of those. Suggesting a high gain directional antenna. I'm not quite sure what it was alluding to, but Alex Pettit's antenna, of course, is a Yagi. So I think it's 17 element Yagi, so that has a lot of those particular features about it. And I guess dishes are reasonably directional. I think we all agree with the idea that the location is quite important in terms of trying to stay away from big RFI producers. From what I have picked up from conversations on SARA, and I'd be interested to see what you guys say, but the general consensus seems to be that ferrite chokes aren't that helpful, but I'd be quite interested to see what you guys think.
I've seen some.
Yeah, sorry, we'll come back to
benefit.
it in a minute or two, Andy. You can say whatever you like.
Okay.
I've only got 8 slides, so for the 7, I'll just go through them quickly. And then in terms of the electronics, certainly from my own experience, I refused to do this for a while in terms of placing the LNA close to the antenna feed point, i.e. up on at the back of the dish. And I was playing around with all sorts of different types of coax cable, but when I did this, it made such a difference, and suddenly the coax cable didn't seem to matter so much anymore. So I've now got an sort of LMR 400 equivalent, which is the KMR, which is like a Me Too version of AliExpress, which is on there, which is probably unnecessary now that I've done that move. I don't know about 1 decibel noise figures and how practical that is, but still. They're still suggesting here, or at least ChatGTP still suggesting using expensive cable. Certainly avoiding RG58 sounds sensible. Short cable run's another thing that we can talk about. Once you've put your LNA close to the antenna feed point, does it really matter? Because I think Ted's, remind me, Ted, how long your cable runs are. I thought they were quite lengthy. But I think Andrew at the beginning was saying they had some problems with a long cable run into their observatory. So I'd be interested to see what you guys think of that. The receiver, bandpass filter, I think we'd all agree that I know Andrew and his team there in Norfolk are not using this particular one, but for most of us, the new Alex Sawbird seems to have revolutionised the whole of this, which contains a filter and 2 cascaded amplifiers. Although again, it'd be interesting to talk about how important the filter is these days, given that the software will do software filtering. How important is it still to filter it out at that LNA? I'd be interested to see what you guys say for that. Shielding the receiver and computer to try and prevent RFI from your own systems. I think that's we'd all agree that was definitely a good idea, but the question is, how important is it? Particularly when you get software like Ted's Easy Radio Astronomy, which seems to do an extremely good job of taking a lot of the RFI out. Local interference, well again, this is the same sort of thing, power supplies, monitors, network devices. Or in my case, because I have my computer box underneath one of my, or near my aerials, and because we're in the UK where you get a lot of dew in the morning, and do something about it collecting in the bottom of the box, I put in these little caravan dehumidifiers, where I think they produce quite a bit of interference, which is a bit of an issue. And then, of course, data acquisition, which is what's incredibly powerful these days. And again, Easy Radio Astronomy, a very good example of it. Averaging and integration. And for those people who use SDR Sharp, the IF average plugin, again, doing the similar type of job. Clean power supplies. Again, be really interested to hear what you all think of that. I know that there's been a lot of talk again on the SARA forum about the importance of a good clean power supply for the new ELEC, but if you do power it through the coax, way up through the SDR and out through the USB, then that seems to do the trick. Obviously put your bias T on, but since Ted has introduced a new parameter on Easy Coal, which means that it will make sure it turns on every time, and I've included that in my batch file. As a result, I now don't forget to turn the BIOS T on anymore, which was my problem right at the beginning, which is what was leading me to power it that way. And I know that some people on the SARA forum, again, or even on this group, have said before that because they've been using either cooling devices at the dish, I think, to try and help cool the LNA down, they've decided to use that as a power supply through to the filter. Is that a good idea? Isn't it? I don't know. See what you think. What else have we got? So ChatGTP suggesting check your local spectrum using some sort of scanner. This business of periodic signals is interesting because we all look at our traces we get back, and we can all see that certain times of the day the RFI goes up, which suggests that there are things locally that are causing that issue. I'm not sure for H-line work how useful it is to try and only observe at certain parts of the day, because certainly with a drift scan, it's the ability to have long scans that really makes it a very powerful technique. And that's it. So if I perhaps go back to the first or the second slide there, and then hand it over to you guys to see what you think of these things. You could talk about anything that you want to, really.
Ferrite chokes. I've been playing around with ferrite chokes. Okay, so I've got short run from the feed from the monopole to the amplifiers, and I've been playing around putting ferrite chokes on those small cables, and I have seen some reduction in noise. I don't know how important it is, but it certainly can reduce some noise.
Okay. But where do you put your ferrite chokes?
So between the monopole and the amplifier, and then from the amplifier to the air spy or whatever detector you're using, the SDR.
So
this is around.
Forgive me, Adrian. Carry on.
I was just going to ask. So you place these are like cylindrical chokes around the coax connections.
No, I've got the rings, and so you just loop the LNA cable or the I forget what the SMC or whatever it is cable through the choke between mounting points.
So you're saying they're the ferrite toroids, correct?
That's right. Yeah.
Oh, toroids. So not those cylindrical ones that they sell for specifically for noise reduction. I see. And do you know which specific toroid material you're using?
Oh no. I mean it's just off Amazon.
I see, because the toroid material itself can make a difference as to the range of frequencies that they will function under. I used to wind some toroid coils myself, and there's different mixes. I think of the one company that was at Amadon, I think that sold those. And so there's different compositions of ferrite that are for different frequencies. Okay. And so I was curious if you used any specific type.
No.
Okay, just random toroid. All right. Okay. Well, those seem to have a lot of common sense and pretty good suggestions there, Andrew. I like the idea because I've done that, and very disappointingly, and that's that one suggestion that you use a wide scan kind of a survey of your area for RFI, and to my disappointment, I have done that and just almost wept because I'm just deluged in military RFI where I live, and I live very close to a military air base. And as a matter of fact, if I point my antenna to the south where I would want to point for hydrogen line, I get all kinds of F-35s and Osprey and C-130s and all these military aircraft that fly right through the path of where the antenna is pointing. I used to have problems with that even just watching TV satellites. They would fly right through the reception and just blot out the signal whenever one of these aircraft would fly right through the path of where the antenna was pointing. And so that's one problem that I have absolutely no solution for, at least for my home anyway. So I'm resigned that any drift scan that I would do, and usually they're pretty good at night, although we do get quite a bit of night activity also. I don't know, they fly out of, this is the Miramar Air Base. I'm sure you guys have probably seen or heard of it. It's kind of like the Tom Cruise, those Top Gun pictures were filmed. And so it's a Marine Air Base there that has all kinds of fighter jets and cargo airplanes and these Osprey sort of pseudo helicopter airplanes that have the propellers that kind of swing forward, when they go in flight and so forth. And there's a huge population of all those things that just constantly fly. The only advantage of living close to this airbase is whenever they have the air shows, and then I don't have to go to the airbase to watch it. I can just sort of sit in my backyard and watch like the Blue Angels do all their aerobatics. And it's kind of fun when they kind of fly over my house at about 300 feet going, 500 miles an hour, and just zoom over, and you think that you're just going to rattle the roof off of your home. But anyway, the RFI doing kind of that survey, pointing one of these little, not necessarily a Yagi, it's this other thing. It's called a Logi. It's a log periodic time antenna, so for wide bandwidth, and just kind of a small one, handheld, and then with my SDR and just kind of swinging it around the 1420 frequency, and boy, just anything kind of pointing towards that direction, towards the south, slightly to the southeast, is just a raucous bunch of spikes and stuff, and things just popping up all around that frequency. So my RFI environment is just really, really bad. No correction for that, other than just go somewhere else to do my observations, which is not practical. So somewhat of a discouraging thing for my RFI, my QTH here, my location for the detection of weak signals.
So looking back at what we discussed earlier on, interesting that ChatGTP here has suggested ensuring collector polarization, but in our discussion before, we were commenting that the hydrogen signal from space isn't usually polarized. So are we suggesting that's probably an error?
The only potential advantage would be not necessarily due to the signal itself, but from your external ground noise signal. So usually, if you have horizontal polarization, you might be picking up a little bit more ground noise if you're a little bit closer to the horizon, or just general ground RFI, than if you try to use the vertical polarization. That's usually not going to pick up as much of the ground noise and RFI to some degree. So that's the only advantage I would think would be provided by trying to use a given polarization, would be that, and to reduce somewhat the ground effect of RFI by using the vertical polarization rather than the horizontal, where you're picking up more of essentially the horizon, but not any RFI that might be occurring from that perspective. So trying to go with a vertical polarization would be what I would suggest. And since it doesn't matter for hydrogen, then that's, it shouldn't make any difference on the hydrogen signal itself.
Okay, so the next question, as I mentioned when I was doing the presentation a minute or two ago, is this question of short cable runs. So whereas it's very easy to say that a short cable run is vitally important if the LNA is located near your SDR or your computer or your receiver, once you've placed the the low noise amplifier, say immediately behind your dish or whatever antenna you're using, how important then is it what type of cable you use or how short those cables are?
Well, with our experience, our radio shed where the main computer is about 30 meters from the dish, and Lord knows what cable, the coax cable we were using, but we lost about 10 dB from the amplifiers and SDR amplifiers in the dish down to the detection in the shed using coax cable. And so then that was what prompted us to move everything to the dish. So we have the amplifiers and the SDR right next to the monopole, and then we've got a 5-meter USB cable from the SDR down to the computer, and then we use network to the shed.
Yeah, I would agree. I think cable is still important, even if the LNA is right at the dish. 1420, you're still getting 1420 out of the LNA. If you had some kind of converter that would drop it down to, a couple hundred megahertz or something, that might not be as much problem. But 1420 is still fairly high frequency for coax. RG58 would not be something you would want to use. RG6, although it's 75 ohms, but I think for reception it's not. I don't know how many dBs lost between 75 and 50 at your SDR input probably, but it's not probably going to be significant. But since RG6 is designed for like satellite TV, and the signal coming off of the LNBs for satellite TV is in the range of from like 800, 900 megahertz on up, 600 on up to over 1,000. So it's in that ballparkish range for hydrogen. So RG6, again, I don't have any practical experience, but from what I've heard, it's fairly usable also. I don't think that 50 to 75 ohm is going to make a huge difference, but you definitely want to use fairly decent cable at 1420, regardless of whether the LNA is out there. You could then add another small gain amplifier at your LNA if you think you're having losses on your coax run. I know for that back dish that I have that I'd kind of like to maybe convert over for the hydrogen work. I also have a long run. It's all the way from the back of my yard property to inside the house, and I buried that inside PVC tubing from the dish. The coax from the LNB at the dish goes right into some PVC tubing at the concrete base, and then that was underground all the way run to my home. And that was like a special cable, so it actually has two RG6 cables in there, because one was for the S band and the other was for the KU band reception, and then it has lines for the power for the motor, and also lines for the polarization. The LNB for satellites, they have it's kind of an interesting construction on the feed. It's a dipole. It's not at the end. It's not at the side of the cavity, but it's at the very back of the cavity, and it protrudes into the cavity, and then it has like a small servo motor it's like a little dipole that then can turn 90 degrees to change for the polarization, because satellites put out the two signals, one horizontal and vertical polarization, at least the old C-band satellites. And so it had all kinds of cables running to it. And it's RG6, so I was planning on using the same cable. Hopefully it won't be, because I don't want to make another run if I use that back dish. But yeah, 1420 at any kind of significant run, you could easily get significant signal loss with bad coax. So I would think that that's still pretty high on the list.
All right. Okay.
Regardless of the LNA is.
How long are the cable runs in Little Thompson Observatory, Ted? Or maybe he's left us.
I thought the suggestions were pretty useful. They're all good ideas. Do I follow them all? Not particularly, but they're good intentions.
Okay. Well, so the next slide. So I suppose the question I want to ask you guys what you thought about shielding. How much of a difference does it make? And if so, which bits do we need to shield in your experience?
I make sure to put a plastic bag around it.
Well, that's true, especially here in terms of things getting wet and getting ingress of water into the cables. That would ruin the cables and ruin the effect. And a sawbird is certainly not waterproof.
Yeah, plastic bag. Wow. Um, you know what I hear from a lot of people is that if you use an external screen, that a lot of monitors are the ones that are really nasty about putting a lot of RFI out. And they don't mention the monitors here, but the monitors is what I hear maybe sometimes are the worst culprits for RFI. That's just secondhand though. I tend to use laptops, so it's built in. So I don't use external monitors, but that might be something to consider if you're having multiple screens and you use external monitors, whether that's providing a problem.
There we are. Just been added into the instructions. Okay, right. I mean, that was fits in with what Andrew said at the beginning about going to that radio event and LCD screens causing terrible problems with his radio astronomy experiments.
Yeah.
Okay, and I think so. Okay, this is pretty much what we've just been talking about. So that was the next question. Sorry.
Chat GP Adrian. So yeah.
I'm sorry.
So says Chat GP Adrian. Yeah, that new addition.
Chat, yeah, definitely chat. That's for sure. You know, I can't predict it. You know, the only prediction that I have is because we're obviously on the bay here, and it's a big naval station here, where they bring in the aircraft carriers out here to what's called North Island, which is the harbor right off San Diego. And I have noticed that whenever the carriers come in, they launch all their jets out from out at sea. I guess they don't want to sit there. They don't want the carriers sitting with all the jets on the deck. And so whenever those carriers come in, boy, it's just wave after wave after wave of all these fighter jets and other aircraft that are then sitting here on the ground air base, and then they're just maneuvering round the clock practically. Anyway, so much for me harping about my military RFI. So what do they call it? The sound of freedom.
So the last question I wanted to ask you all, this is the last question on this presentation, was how important do you think a clean, regulated power supply is? And which bits of the system need it?
Big one. Just take any switching power supply and just chunk it and throw it in the bin.
You did have something about using bias T rather than power supplies, but some laptops or computers, the power that you get out of the USB isn't as regular as you would like, and you can get filters to go into the USB line. But so sometimes using bias T, you get worse signal to noise than if you used a good power supply. But the cheap power supplies, which are switching, do introduce an awful lot of noise.
Well, the power supply in your computer is a switching power supply.
Yeah.
So what I would do is just go for a linear power supply. Use linear regulators, you know, and then just go old-fashioned with a linear regulator power supply. And you know, the old if you need 5 volts, the old 7805 linear power supply regulator chip, and just build yourself a nice linear power supply and just stay away from the switching power supply. It's just I tend to hear the the power from your USB is not that clean. You know, if you
Yeah.
put that out the scope, you see all kinds of. Usually, it's lower frequency, you know, because the switching is usually down in the maybe hundreds of kilohertz type range or something. I don't think they usually go, but the harmonics from that can just be really nasty. All it has to do is go through some kind of a nonlinear device, a rectifier diode or something, and then boy, you just can generate all kinds of harmonics that could go all the way up to whatever. You know, I'm not sure, you know, on that experience, but I think if you used bias T with a linear power supply powering it, you might get a lot cleaner supply voltage and better regulated too than just whatever comes out of the USB port from your computer. But anyway, that's just my opinion.
Yeah, well, fair enough. Well, that's why I've asked the question. So are these the type of things that you're thinking of?
Let's see. Switching. No. There's one here, the linear power supply. That's what I would go for. Something that says linear, not switching.
Is this the
The
P50
wall
one here you're talking about?
Yeah, like that. Yeah, not necessarily for those voltages or that high power. And you can put something together very easily. Just go to your little your local electronics store or Amazon or something and get yourself like a 12-volt transformer, a little transformer that maybe puts out a couple of amps at most. Buy yourself a handful of the chip. It's called kind of the old standby. It's called the 7805. It's a positive voltage regulator that you feed it the 12 volts. You have to put a couple of capacitors on one side, input output, and you get out a nice clean 5-volt voltage to power all the LNBs and so forth. No spikes on it. It's not going to have any of the harmonics from the switching circuitry and whatnot. That's what I would do. That's what I would use.
Adrian wants a very heavy power supply. Lots of steel in there in that transformer.
Well, you don't need, but just maybe even just not even an amp. I mean, these things don't draw, but like maybe 100 milliamps or something. So you don't need a very, very heavy transformer.
Yes, but the equivalent would not have the transformer. That's what I'm saying.
But it has the switching, and then all the different.
Heavier is the better.
Yeah, well, that's what I'm saying. Yeah, so the transformer would be for the linear power supply. You've got to drop down that house 60 cycle down to somewhere in the range of 12 volts or so. That's a fairly common voltage, and you need a little bit of overhead for the regulator. Now they do have these other newer units that are called LDOs, or low dropout voltage regulators. So there's other you can just look these things up, and they'll have different voltage ranges: 5 volts, 12 volts, 6, whatever. Some of them are adjustable. You can just draw a little circuit with a little variable resistor, and you can actually adjust the voltage that it regulates to. But whatever voltage you want out, you might need something like a 1 or 2 volts higher on the input side, just to cover the overhead. The 7502 is not all that efficient, so it might get a little bit warm. But again, you don't need very much power out of these things. So, I don't know, if you have any basic electronics background, you can put one of these things together. A little bridge rectifier on a transformer and a voltage regulator output, and feed that through a bias T. You get a lot cleaner power input supply than anything out of a switch or USB port. It's convenient, you don't have to build anything or attach or anything or whatever, and you can just run it straight through the built-in bias T on the SDR, and just feed it right off the USB. Unfortunately, you can't do anything about the SDR because that's going to be running directly off. But you have so much circuitry inside the SDR that you probably be able to filter out most of the junk. I would say more for the LNB. Go for the linear on the LNB. You can't do much on the SDR, but unless you go into its guts and power it independently. But anyway, just my opinion.
So, I mean, does it matter what sort of power supply you use for the computer? I mean, if you put a linear transformer on
No,
the bottom
because
of
nah, all the computers are going to have switching power supply. If you're using a laptop, the thing that you plug into it, that box, that's switching, because it's a much more efficient type of supply. You just get much better efficiency in converting the voltage that you want into the voltage you want out without generating extra heat and whatnot. It's just more efficient, but it's just noisier. I mean, for most applications, you don't care. But especially the low noise, the low noise amplifier, you definitely want the cleanest voltage on that guy, for sure. So the computer's not, no, it's built in, unless you built your own computer and somehow managed to finagle. Some of the old timey, boy, I remember some of the old, oh my gosh, some of the very earliest computers that were not even commercial kits. They were just kits you put together. They all had linear power supplies. Back then, people didn't have switch. I'm talking, oh my God, 1978, 1979, very early 80s. All those computers, those early M-size and whatever, they all used linear power supplies, big chunky transformers that all went into linear power supplies. That it's just direct conversion from the AC through rectifiers to DC, and then some kind of voltage regulation, but not the switching aspect of it. But anything commercial nowadays, it's all going to be around switching. This is just so much more efficient. I mean, you don't care for a computer, it's just not going to make any difference.
Okay. Yeah, well, thank you very much for that. I've learned a lot tonight. And so thank you all very much indeed. Is there anything else anyone would like to say before we finish the meeting?
In terms of looking at things that vary, I mean, nobody's mentioned diurnal variation. I don't know whether the signal noise changes, but certainly diurnal variation has a big impact on the signal that you're receiving.
Okay.
You mean more noise during the day, or just because there's more people with activity on RF?
If you're doing a drift scan, your signal will be higher during the day than it will be at night, or the noise level, the bass level, that will be higher during the day than it will be at night.
Just the temperature,
just the temperature.
You mean the external radiation temperature, or just the component, the receiver, low noise amplifier, not meeting warmer?
I believe it's the sort of ambient temperature that your monopole is picking up.
Sure. Okay. Yeah.
The heat off the dish is a background that changes from day to night.
And the dish and whatnot. Yeah. Unless you live somewhere where the temperature just doesn't go down that much at night. You guys are lucky in England, but sometimes, I mean, where I live, is the weather outside is fantastically. It's probably like 78 degrees Fahrenheit, and I live like maybe 5 miles from the coast. But all I have to do is travel like 60 miles inland, and the temperature is going to be 116 degrees Fahrenheit, and the humidity is going to be like 5% because it's desert. Just 60 miles can make that difference between here and the coast and going out to like a little town called Borrego Springs or whatever, which is out there in the desert, and that's going to be a huge temperature difference, and so that would be a definite difference during the day and night. But oh, there you go. Wow, that's Ted found it. Huh? Oh my gosh.
That's a reference. That's all. I'm fascinated.
Well, I'm telling you, it's
W1GHS, GHZ, of course.
Oh, it's Well, I knew I had seen that somewhere, so I wasn't making it up. But I mean, that's just one possibility, I guess the only other way that I know of to generate a parabolic shape is that's even been used for parabolic. I think there's even a telescope that's been made where they take like a mercury pool in a very large sort of flat area that sort of resembles what a reflector would be, and then you spin it. And as you spin it, the centrifugal force forces the liquid to form like a parabolic shape.
Yep. Very nice shape, but
yeah.
only vertical. Only vertical.
Yeah. So that if you use maybe like epoxy or something, and you had a large enough area and you could spin it at very constant RPMs, you could definitely generate a parabolic shape. And of course, the faster you spin it, the different focal point and so forth for the DFT size for the reflector would be. But then you would just have to wait for the thing to cure. And
yep. Then you pick out the flies. Yep.
Yeah, the flies and whatever, just make sure it's, you got a nice and close place where you do this and have a dust-free environment. That's funny that you were able to find that, Ted. That's amazing.
We'll stick with our geodesic design.
There you go.
I thought that was very clever. Yeah, that's neat.
I'm telling you, people are very innovative when they're sort of trying to go off and come up with a novel idea of how to do things, and the old hacker mentality of just trying to find a way around the difficulties to get things done. Anyway.
Well, the geodesic design is quite magical when you're building it, because you drill all the holes to specific measurements, and then when you bolt it together, it just naturally forms a parabola.
I like it. Yeah.
Yeah. It's a lot easier, I think. Wow. Oh boy. So Andrew, have you done any more mapping recently of with your solar cooker dish? I'm fascinated because I'd like to.
Yeah. Well, it is carrying on collecting data at the moment. I've been spending most of the last month on the muon detector dashboard, which has, if I had any hair, pulling it out. But if it wasn't for Miguel and my son, would not exist to this day. As it seems to involve installing things under Linux, and I tend to agree with Andrew's perspective on Linux. Everything is forgiven for Windows, but obviously it doesn't do sometimes what you want it to do, and people write software using other platforms, and you can see as well how powerful Linux is, and it allows you to do things which are not easy to access from a Windows environment. But we got there eventually, and I've seen how incredibly powerful Grafana is, and of course it does have a Windows version as well, so I'm surprised that we don't, as amateur astronomers, use it more often, because once you've got it up and running, the power to generate graphs. I mean, I know Ted, you were kindly trying to write a muon, or did write a basic muon dashboard for me, but it was very difficult trying to generate a wide range of graphs, wasn't it? And that's the issue. Whereas in Grafana, you end up with a high-level environment by the end, that you enter queries at a much sort of more simple sort of language, which are then generated, and you can do things like just copy the windows and then modify them. You don't even have to do it from scratch. But it's I'm just surprised we don't use it more often. But for all sorts of different types of radio astronomy, including H-Line. As far as my radio telescopes are concerned, my 3 different H-Line scopes are continuing to collect data. The ptarmigan array is now on longer integration times, so I can see what difference that makes, if any. The solar cooker one and the Alex Pettit Yagi are there trying to fill in the gaps, because previously I had a few data points, but when Easy Radio Astronomy tried to graph it out, they didn't give such a nice diagram because of the graphs. So I'm trying to see where that leaves me, and then I'm going to have the issue of trying to deal with the radio interference, which particularly the solar cooker seems to be very good at collecting radio interference signals. Maybe because it's bigger, I suppose, but that's something I have to find a way of dealing with. Begging Ted for help, I'm sure. But so we'll come back to that, and that is very, very much on the agenda, because I know there's a a lot of people who are keen to see the results of that and see how that managed to get working. A couple of questions I'm just wondering about with it is, one, I noticed that Andrew was talking about his feed and talking about having a flange at the bottom, and I'm wondering about whether adding a flange to my antenna would make a significant difference. And the other thing that's been talked about a lot on SARA is about ground noise. Of course, my dishes are quite close to the ground. They may be aiming up towards the sky, but they're only a metre or so at their lowest point off the ground, or about a metre off the ground. So ground noise potentially is an issue, and I'm wondering whether it's worth putting an extra bit of something around the edge in an attempt to try and act as a suppressor of ground noise, and whether that would make a significant difference. So a few things to think about. I do have an issue that I'm got a lot of trees around the garden and other houses quite close by, so it is rather difficult to try and avoid interference. But if I can try and identify some of those areas, I might be able to do something about it.
I guess ground noise would depend on the shape of the beam. So if your beam is very flat, you're going to pick up more ground noise. Whereas our feed horns, which are sort of cylindrical, point fairly up. So even though we have them low down on the ground, we're not picking up much of the ground.
Sorry, I'm talking about my dish. I've made a dish out of, well, it's called they're sold on eBay.com or AliExpress. They are these 1.5 metre repurposed satellite dishes, essentially, like satellite dish designs. But as a feed,
beam width of that dish.
Well, the actual antenna feed itself. I think the problem here is over illumination. What they call over illumination of the dish. So
that's what I'm worried about. That the antenna is
so
collecting stuff from the side, outside of the dish. Yeah,
exactly. And I think that's where the skirt that you're describing to, because that tends to form the beam much better to the area of the dish, rather than having it splay out more along the sides of it and then picking up that ground noise. So I think those I don't know, they used to call them chaparral feeds. I don't know if that's really the correct term or not, but you have these concentric rings right at the opening of the waveguide of the antenna, and then those tend to shape the beam, the shape of the beam that the actual monopole inside the antenna is picking up the signal from inside the area of the dish, and not from the outside broader part of it. And of course you can, then there's the other problem of what's called, I guess, under illumination, where you don't use the full area. If you have too sharp of a beam, then you don't pick up the area from the periphery of the reflector, which is actually where most of the area is. So it's kind of like a fine balance of not going outside that area of the reflector and staying inside of it, but not too much, because then you lose some of the signal that's coming from the large surface area, which is on the periphery. And so it's kind of like that fine tuning of where you get that feed sort of illumination. I don't think the ground proximity would, unless I don't think the ground proximity itself is the problem. But of course, if you're over illuminating, then you're just going to be picking up all that ground noise. It's kind of like what people suggest, in determining your system noise, where you're supposed to point it at the ground and then get that signal, and then pull it up at the sky, and then see what the difference is between the two to figure out what your system noise level is. But oh boy, just deciding these things. I just wish I were an engineer. I'm sorry, I'm a biologist guy.
Well, it's impressive listening to you. Okay.
But I've been interested in electronics since I was a kid, so I've had a ham radio license for a long time. So it's kind of, I wear a hat and, switch over between test tubes and transistors.
Okay. Shall we set a date for the next meeting? Do we want one next month, or do we want to have a break over the summer and restart the month after? What do people want?
I'm game for any schedule. I'm retired.
Andrew, Ted, how do you feel?
Set the schedule and see who shows up.
Okay.
Yeah.
Andrew, how do you feel?
I'm easy, you know.
Okay.
So, set one for next month.
Okay, so next month, let's have a look. Usually we generally go for the first Monday, so is it Monday the 4th of August? Is that okay?
Yeah.
Okay, so Monday the 4th of August it is. Just make
Oh,
myself.
one last quick question, Andrew. How's the rust situation on the solar cooker?
Oh,
The corrosion?
I've spray painted it all. Well, firstly, I've pulled off the mylar coating, which comes off quite
Right.
easily, and I've spray painted it with aluminium and zinc spray paint, which a local hardware shop was selling quite cheaply, and so I bought several cans. That seems to have done an excellent job. I don't really get any rust. And every so often I go out and spray a bit more on. But I mean, they are light steel, and when I first got it did start very quickly to have some little spots of rust appearing around the edge. But I got in very quickly before it got any further. I guess one question is that paint better, or are you just better off using something like Hammerite, which is just a brand name here, which you tend to think of as these anti-rust paints that describe you can paint directly on rust. They seem to be quite good at protecting things. I don't know whether one of those would be a better option or not.
Probably not. Not at 21 centimeters. If you're trying to use that for your 22 gigahertz water masers, then yeah, you might. I don't think you'll be able to use your solar cooker for that. The surface accuracy is probably not going to cut it.
No.
So,
No, well, that's.
I don't know what kind of dish you're going to use for that, but you probably need a much more accurate dish than that.
Oh, it's just an
That's
offset,
fascinating.
just an offset 1 meter satellite dish, similar to what Edgard uses.
Yeah,
Yeah.
that would probably do it. Yeah, for sat
Okay.
use. Yeah.
Okay. Well,
Okay.
what I'm going to do now is I'm going to formally bring the meeting to an end. So thank you all very much. I'll send out an invite for the next meeting. So I'm going to close down the recording now.
Thank you very